The sky is busy tonight. Curtains of aurora drift over high latitudes. Space weather blogs speak in soft alarm about X-class flares and geomagnetic unrest. News tickers on the other side of the ocean mention a cluster of earthquakes and wonder if the sun has somehow shaken the ground. In the last 72 hours, attention has folded inward. Eyes have narrowed to coastlines, grids, and airports. The noise is bright. The noise is loud. The noise is human. But the signal sits far from home, quiet and patient, and it has moved while we were looking down. An object labeled 3I, tracked through specks of light and subtraction, has begun to disobey the simple path that gravity offers. The fit will not settle unless you allow a new term. Observers speak softly about a fresh, non-linear push. Some call it non-gravitational acceleration because that phrase is familiar and safe. Others slip and say active acceleration as if intention has bled into the numbers. The change is small when you glance at a map and gigantic when you remember that distance makes tiny angles profound. A few hours of gentle thrust can echo across millions of miles. A whisper becomes a turn. Amateurs always go first. A late-night stack from a modest half-meter rig shows tiny residuals that refuse to vanish. A second stack from a different hemisphere lands within the same rounded bounds. A professor known for being comfortable with strange space rocks asks the question that professionals answer with careful silence. Official updates summarize tracking windows without explaining why one window has shifted. Vital nouns remain absent. The public sleeps. The data does not. Between the lines, the story develops an engine. Between the lines, a maneuver begins to matter. Our role is simple. We will hold the picture steady. We will arrange the files in a calm order and guide you through a darkness that invites imagination without surrendering anchor points. This channel is a documentary for sleep, which means pace and clarity matter as much as intrigue. You are not asked to agree. You are invited to listen and consider. If you drift before the end, the ideas will wait for you tomorrow. If you stay, we will draw a clean thread through a crowded sky. If this quiet investigation helps you, consider supporting the work in a gentle way. Subscribe so you can find your way back when the next chapter arrives. Tap like if the slow cadence keeps your mind from racing. Share this with one thoughtful friend who enjoys cosmic puzzles without panic. In the comments, tell us where you think 3I might be steering and what evidence you would trust. Use headphones if you want a softer room. Breathe slowly. We will be here each week, building a calm record of what the sky is trying to say. Now, dim the lights, let the room settle. Picture the sun as a lantern that sometimes flickers. Solar flares pour charged particles into the wind, and they race along invisible rails toward our magnetosphere. Power companies run checklists. Subways decelerate. On another channel, someone links earthquakes in Japan to the flicker because timing is persuasive when fear is awake. Those are honest stories about natural stress. They are not the only story. In a universe this wide, many things will happen at once. The closeness of their dates is a convincing illusion. The term for this is cosmic noise. It can soothe and it can mislead. If you step back, the rhythm of the sun is a patient cycle. Solar cycle peaks arrive every 11 years on average. The numbers blur into friendly clusters. Active regions flare and then rest. The magnetosphere bends and rebounds. We see auroras and we take photographs. Earthquakes obey the slow language of plates. They build and release along faults that remember older pressures. None of this is trivial. All of this belongs to Earth. What belongs to space tonight is the drift of a small body that has begun to behave as if something inside it knows the word steer. That is the signal. It sits under the noise like a bass line. You only notice once someone points to it. Here is the compact science that matters for the file. When a comet is pushed by vents of gas, we see a tail, and we call the extra motion non-gravitational acceleration. Models use a few rounded parameters for thrust, area, and mass, and they fit the curve. It is tidy when the light shows a plume. It is less tidy when the curve requires a push and the light refuses to confess a tail. The earlier interstellar visitor 1I was a lesson in that discomfort. The second, 2I, behaved more traditionally. Now, a third object appears to accept the curve and refuse the plume. The residuals ask for a small thrust lasting hours. The images offer a clean profile that does not bloom. The mind builds a bridge between the two and writes the word propulsion in pencil. There is a reason a single restricted image can change the temperature of a conversation. The Mars Reconnaissance Orbiter has returned uncounted useful pictures for years. One frame that never quite makes it to the public archive becomes a rumor with teeth. We are told it was nothing. We are told processing failed. We are told to be patient. Patience is appropriate most of the time. It frays when another spacecraft returns a whisper that feels related. The Jupiter Icy Moons Explorer has a long, careful flight plan. Along the way, it listens. Somewhere in that long, listen, someone claims there was a narrowband pulse near 1.44 gigahertz. That is a communications band. It is also a place where odd reflections can masquerade as intention. The calm position is simple. Note it, file it, ask if the timing rhymes with the new push. You are free to treat this as a cluster of coincidences. You are also free to interpret the cluster as a pattern that asks for a motive. Our approach takes the middle road. We put real space weather in one folder and put rumors about earthquakes in another. We place the clean astrometry in front of us and add a row that says new acceleration appears. We pin the alleged pulse beside that row with a gentle asterisk. We highlight the missing image without demanding a grand reveal. Then we ask the smallest possible dangerous question. If an object can steer without declaring a plume, what does it want from its next position? That is not fear. That is navigation. This is the opening file in a cabinet that holds a few careful words. Cosmic noise is rising, and that is fine. It gives the world something to talk about, while a small body chooses a slightly different future. We will not tell you what to fear. We will not shout. We will examine the steering idea with more specificity next. Before we compare burns and timelines, pause on the quiet picture. A sky full of brightness and alarms. A tiny signal that changes the curve by a breath. If something can push without leaving a tail, what would it gain by nudging itself now rather than later? The rumor feels tidy. A flare erupts. A quake strikes. A thread on a forum ties them to a distant traveler and calls it a domino chain. If an interstellar object can push itself, the story says, perhaps it brushed the sun and shook the plates, a silent cue rippling across space. It is a smooth story, the kind that comforts because everything aligns. It is also a story that does not survive basic physics. The more precise the steering we infer for 3I, the less believable it becomes that it would waste effort on random terrestrial drama. Precision and waste do not share a cockpit. Calm returns when we trade a neat myth for a measured file. Start with the light itself. Solar flares are born inside twisted magnetic fields that snap and reconnect. Energy stored in magnetic loops is released into heat, bright light, and fast particles. A strong flare can launch a coronal mass ejection that runs outward near 1,000 kilometers each second. The total energy in a large event can rest around 10 to the 25 joules. These are house numbers, rounded for sleep. They are also more than enough to explain the show without any outside push. The sun owns its storms. Its cycle rises and falls about every 11 years. Active regions come and go. Charged particles travel along magnetic rails. The physics is fierce and local to the star. A visitor passing through interplanetary space does not reach back and pull those strings. Now walk the quiet ground. Earthquakes are plates releasing stress along faults that remember old pressure. Most large quakes happen at boundaries that ring the Pacific and run through Asia and the Mediterranean. Reviews that hunt for a reliable link between solar storms and earthquakes return signals that are inconsistent and weak. That is the polite way of saying there is no proven trigger from space. The mantle is not a radio that you can tune with a distant pulse. It is rock. It creeps because heat rises, because slabs sink, because continents grind and slide. When a fault slips, the reason is stored stress and geometry, not a whisper from a comet or a traveler between the planets. Turn back to 3I. The new acceleration seen in the fits asks for a small push applied for hours rather than a flash that ends in minutes. Add a few millimeters per second here, add a few more there, and a path will drift by thousands of miles weeks later. That is efficient. That is what sailors do with a light wind and a patient hand. If you own a thrifty engine or a reflective sail, the smartest strategy is quiet and exact. You wait for geometry to work in your favor. You nudge when a nudge buys the most future. You do not light a bonfire on the sun to turn a wheel. You trace a clean arc and let gravity multiply your choice. Consider an energy budget that a careful pilot would accept. Imagine a compact engine that can deliver a steady push of a few newtons to a body with the mass of a small mountain. Most of that capability would be spent on steering, not on spectacle. Short burns placed at smart times multiply their effect by orbital leverage. The sun offers free gravity for anyone who knows when to lean. An object with finesse would ride that gift. It would not spend hours trying to stir a star into drama or nudge plates beneath oceans. Those outcomes would be wasteful, noisy, and useless for navigation. A pilot that can read celestial mechanics would choose thrift over theater every time. Picture the two scenes side by side. In one, the sun is a bright hospital lamp, and a flare is a sudden crackle of heat. In the other, a craft-sized mystery closes a switch inside its own shadow and whispers a few centimeters per second into its motion. The first scene floods a solar system with particles. The second scene draws a new line on a quiet plot that few people watch. These are different worlds of action. If you are the surgeon under that lamp, you move your hand a millimeter at a time. You do not wave your arm and hope the cut lands where you want it. The image is simple and it is enough. A careful hand makes careful outcomes. There is another reason to question the domino chain that has nothing to do with energy and everything to do with intention. Causing a show on the sun or on Earth would be the worst kind of advertising. It would wake after hours teams. It would prompt emergency calls and cross-checks that pull attention to the exact patch of sky you would keep sleepy. The cleanest way to hide a maneuver is to fit it under the natural rhythm of the heavens. Let solar storms be solar storms. Let weather be weather. Let headlines point down while the burn lives inside a window that no one is primed to celebrate. Camouflage is best when it looks like ordinary time. Grounded speculation belongs here, not as accusation, but as a model. Institutions love order. During space weather, operators triage attention toward power grids, satellites, and airlines, because those are the places that need care. A quiet orbital tweak by an off-world traveler during the same window will sit in a lower folder by rule, not by plot. The public conversation fills with aurora photographs and flight advisories, which provides a kind of natural cover. A rumor about earthquakes then leaps the gap and pretends the cover was designed. It was not designed. It is simply how attention works. Noise grows. The signal chooses a lane beneath it. The file becomes harder to notice unless you are already looking. Hold the image of data instead of fireworks. Residuals on the orbit fits thicken into a curve that smooths only when a new parameter is allowed. The time tag on that curve matches a night when a different set of headlines kept most eyes on weather maps and power dashboards. A two-line element set slides enough to make tracking teams rewrite a plan by a modest percentage. The confidence bars do not shrink, but they rotate just enough that a telescope pathfinder must be redrawn. These are dull artifacts unless you are interested in steering. If steering is your interest, they read like a journal entry written in pencil. Not loud, not grand, but true. Finally, place the rumor beside the record. The domino chain demands a cause for every coincidence. The file we are building demands one thing only: that the numbers for 3I look more like a choice than a drift. The sun does not need help to flare. Plates do not wait for a beacon to slip. The motion that deserves your attention is subtle and compounding. It speaks in centimeters per second and in hours of patience. It speaks in windows that open at night when the planet is busy with its own weather. If that voice belongs to a pilot or to hardware that acts like a pilot, then the question we carry forward is not whether a traveler lit the flares or shook the ground. The question is the next waypoint. Where does a careful hand want to be when the geometry turns in its favor? Strip away the headlines and lay the plots on a quiet table. A faint bend appears where a clean two-body arc should pass straight through. It looks like a smudge in the corner of a page. It feels like the soft click of a hidden latch. The real story begins there, in the small place where gravity alone no longer closes the book. We are not chasing thunder. We are reading pencil marks. We are looking for intention inside arithmetic that should have slept. Orbit fitting is a patient craft. You collect time, angle, brightness, and the humbler parts of the sky. Then you ask a model to place the object on a curve. When the residuals refuse to vanish, you give the solver permission to add a gentle push that does not come from mass. The old language calls it non-gravitational acceleration. In practice, it behaves like a light hand on a tiller. The tidy way to think about it is a small millimeter per second here, another millimeter per second there, spread over a few hours. The change is tiny in the moment and oversized in the weeks that follow. The covariance ellipse rotates. The window for a telescope slides by a modest percent. A schedule that looked safe yesterday begins to look optimistic. That is how a whisper becomes a plan. Hard facts are stubborn things, so we cluster them and keep them near. Interstellar visitors have shown this split personality before. 1. I drifted like a sliver and asked for a push without declaring a plume. 2. I carried the classic coma and tail that make outgassing an easy answer. A third arrival that bends without a visible tail would not be a myth. It would be a pattern. In that pattern, the safe word is driver. A driver can be thermal vents, a sail that listens to sunlight, or hardware we have not met. The fit does not care which driver you prefer. It only asks to include a term that points in a direction that makes the curve go smooth. Grounded speculation says this new bend is not a flare in disguise. It blooms at a time when geometry pays well. It behaves like a slow push that lives longer than a flash and shorter than a day. There are ways a natural body could imitate that behavior. Sublimation can be focused by shape. A bright patch can become a nozzle that lives on the day side. If you tilt the spin, the thrust can have a preferred direction, and the orbit will drift along a deliberate line. These are friendly models, and we respect them. They also require a tell. They like dust. They like a halo. They like the photographs to glow. When the images remain spare and clean, the models begin to feel like a coat borrowed for the wrong season. Here, the imaginative leap is brief and careful. Suppose there is an engine that does not leave an obvious plume. Suppose its signature is a rhythm rather than a tail. A pulse that taps the motion gently, a few seconds on and a few seconds off, folded into an hour that looks uneventful to any camera that is not ready to listen. If such a rhythm existed, it might prefer to hide where the sky is already loud. It might choose to speak during solar weather because receivers are busy, or during quiet hours when stations rotate out of view. The leap is not an accusation. It is a question about how a pilot would behave if the goal were to arrive and remain mostly unseen. That question brings us back to files that felt unrelated a week ago. A Mars camera that is said to have had a processing problem on a night that later shows up in our fit. A distant explorer that once reported a narrowband hiccup near 1.44 gigahertz and then moved on. A handful of amateurs who compared notes and found their residuals pointing the same way within rounded error bars. None of these on their own is a revelation. Together, they behave like an outline that someone forgot to erase. The outline does not tell a story of doom. It tells a story of steering. It tells a story of a traveler that values timing more than spectacle and prefers leverage over force. So what does the new acceleration buy? In celestial mechanics, small pushes placed at the right time act like interest that compounds. A few centimeters per second added near a turning point becomes thousands of miles weeks later. A burn plussed when the sun and the traveler and the observer make a favorable triangle will tilt the future path without spending much. If the push points a bit forward, the orbit grows. If it points a bit sideways, the plane tilts. If it points a bit sunward, the speed changes in a way that rewrites arrival dates. With that toolkit, a careful hand can move a rendezvous by days, can skip a planned window, can choose a shadow rather than a spotlight. The calculus is simple. The artistry is in the timing. We should name the paradox that follows and then leave it on the desk for section 2. Acceleration without a clear tail is not comfortable. The models that use sunlight pressure alone ask for an area that feels too big unless the body is a sail or a shard. The models that use vents ask for dust that refuses to show up. The numbers prefer a driver. The pictures prefer a secret. Somewhere between those preferences, a solution is hiding in plain sight. It might be a surface that is slick and dark. It might be a mechanism that breathes without leaving grains behind. It might be a design. Tonight, we do not decide. Tonight, we take the bend seriously and prepare to weigh each answer. Here's the unsettling question that the bend writes in the margins. If the push is a choice and not an accident, what is the next waypoint? A pilot that understands leverage does not push just to see the line curve. It pushes to bring lines together. A meet point, a shadow, a wake. The calendar matters as much as the map. An object that slides past an appointment on a well-known space telescope is not being rude. It is choosing who gets to look and when. We will keep our tone steady. We will keep the pictures simple. We will not race ahead of the file. We will close this chapter with a promise. In the next section, we will hold the paradox by both ends. We will place tails, sails, vents, and engines on the same bench and ask each one to account for a curve that has started to act like a signature. A colder quiet takes over as we leave the headlines behind and walk into a room built for patient questions. Imagine a slate sky without glare, the sun a soft lamp, the stars arranged like careful pins. On a plot that should be routine, a thin line bends where geometry promised it would stay straight. The curve does not shout, it inhales. That breath is small, repeatable, and oddly clean. The paradox begins here. Acceleration without a visible tail asks for a new dictionary. In comet language, the script is simple. Ice warms, gas vents, dust lifts, and sunlight sculpts a flag that anybody can see. The extra motion is labeled non-gravitational acceleration, and the fit becomes neat. With 3I, the numbers want the familiar term, but the photographs refuse to play along. The brightness stays compact. The halo stays tame. The curve still wants a push that lasts hours, as if a light hand rested on a tiller and did not slip. It is not much in the moment. A few millimeters per second whispered into a path so long that weeks later the nudge looks wise. The contradiction is elegant. The driver appears to be present. The signature plume does not. Start with the classics and test them gently. Sublimation can become directional if the surface is sculpted by pits and ledges. A nozzle forms where the sun strikes a cavity, gas escapes, and the push lines up with a preferred vector over a spin that is slow. That can produce a measurable drift with only a faint coma. If the grains are coarse, dust may fall back. If the volatile is more like carbon monoxide than water, the emission can be harder to see in casual imaging. These are honest explanations. They ask for geometry that cooperates and for textures that hide their own debris. They also carry a quiet tell. Over time, a vent that works like a nozzle tends to wobble the thrust as the body rotates, and it tends to gift at least a soft skirt of dust to the light. If careful stacks still show a clean profile after many nights, the classical answer grows less comfortable. Next, lay solar radiation pressure on the bench. Sunlight does not only warm, it pushes. Near Earth, the pressure is roughly 10 micronewtons on each square meter, a round figure that helps us sleep. If a body has an area to mass ratio of several square meters per kilogram, that push can add up to the few millionths of a meter per second squared that orbit fits sometimes ask for. The price is shape. You need something broad and very light, more sail than stone. A thin sheet, a blistered foam, a shard with a skin-like foil, and a mass that does not match its size. We can invent such shapes, but they do not sit comfortably with a compact point spread function that refuses to bloom or flash. Radiation pressure is a good citizen in equations. It is harder to picture without sliding toward a sail that looks engineered. There are quieter variants. Thermal re-radiation can create a small net thrust when a warm surface beams more heat in one direction than another. The Yarkovsky effect writes that story on asteroids over many years. Our file asks for hours, not decades. A brisk Yarkovsky cousin would demand a spin and a conductivity that create a steady bias across a single night, which is possible, but it squeezes the parameters hard. Dust-free gas vents are another path. Pure gases can be nearly invisible in broadband images. Jetting carbon monoxide or carbon dioxide could push without leaving much glitter. That model, too, prefers an occasional glint, a stray skirt, or a shift in color that observers can chase with filters. If those small tells continue to refuse to appear while the drift remains, the natural gallery begins to feel crowded and strained. Hold a vivid image in your mind and test it against these calm facts. Picture a glass dark stone gliding through the lantern light of the sun. No mist trails behind it. No veil catches the eye. Yet when you plot its course over a handful of nights, the line refuses to be a pure conic. It leans a little, like a sailor that knows when to shift weight on a quiet deck. The lean persists. It is not a flash, it is not a stumble, it is a choice that accumulates. If this is a comet with tricks, the tricks are subtle and consistent. If this is something else, the something else values thrift and silence. Grounded speculation can live in that space without breaking the frame. Imagine a crust that is unusually smooth, more like baked glass than powder. Volatile pockets vent through microslits that collimate gas but trap grains. The thrust becomes clean, the dust sinks back, and the coma stays shy. A spin axis that points near the sun during the nudge keeps the vector steady for hours, and the fit cleans up in a way that comforts sober modelers. Or consider a hard reflective patch, a natural bright plate that catches sunlight and acts like a small sail for a while. Area to mass would rise temporarily without demanding a wafer-thin body. Both ideas are conservative. Both ask the sky for a couple of small favors. Neither demands an engine. Now take a single imaginative step and set it down gently. Suppose there is propulsion that hides its breath. Not a roaring plume, but a rhythm that leans more than it shines. A pulse that fires for a few seconds, rests for a few seconds, and repeats until the desired delta V accumulates. A whisper in radio by habit or by consequence near a familiar band, just strong enough to be a metronome inside the machine itself. To a casual camera, this would be nothing. To a patient orbit fit, it would be everything. The lack of a tail would not be a mystery. It would be the point. The craft would spend its propellant internally or use charged particles with an exhaust that vanishes into density so low that it does not decorate the light. In that picture, the elegance of the curve is not an accident, it is a signature. Hard facts should keep us honest while we explore that step. Interstellar Visitor 1 behaved like a body with a push and no obvious tail. Interstellar Visitor 2 carried a classic coma and made the old language easy to trust. A third object that writes the first behavior again is not proof, but it is a pattern worth attention. Typical requested accelerations live around a few millionths of a meter per second squared, a round magnitude that a modest engine could supply to a small mountain if the burn is long and the thrust is thrifty. Sunlight pressure alone can do the same trick if the area to mass is high enough, which returns us to sails, foils, and skins that look suspiciously deliberate. The science is an anchor. The inference is the drift we follow from it. Ask the unsettling question that this paradox keeps returning to. If the driver is quiet and dustless, what is it trying to protect besides efficiency? Non-disclosure is a tactic. No tail means fewer automatic alerts, fewer amateurs chasing glow, fewer public images to argue over. A clean point source keeps the conversation inside ephemerides and covariance ellipses where only a few readers linger. If intention lives here, the intention is not to impress. It is to arrive without a crowd. That motive, if real, would favor pulses over plumes and hours over minutes. It would prefer nights when attention is elsewhere. It would draw the path that skirts appointment windows rather than courting them. We close this chapter without verdict and with a bridge. The tailless paradox can be solved by nature if we grant it a texture that cooperates and a handful of coincidences that endure. It can be solved by design if we accept a machine that values silence and thrift. The next file asks us to inspect a different set of clues. There are reports of brief plasma traces that look less like sparks and more like a nudge. If a trajectory burn has begun to write its own footnotes across faint images, the case for deliberate steering strengthens. We will follow that handwriting in the next mini-part and measure whether the marks on the page are fireflies or exhaust. A thin streak shows up in 2 frames like a thread of cold fire. The field is calm, stars are steady, the seeing is ordinary. Yet in the stack that an observer named Jaeger built from a simple 30-second rhythm, a sliver blooms just off the object and fades again. The shape is not long enough to be a full trail. It is not broad enough to be a halo. It sits beside the point source as if a match were struck behind a cupped hand. If this is noise, it is a polite noise that repeats only when the traveler passes a familiar angle in the light. First, we strip the mundane masks from the face. Cosmic rays write jagged diagonals that slice through frames without caring about sky geometry. They seldom echo in the same place across separate exposures. Hot pixels sit, stubborn and square. Satellite glints wander across the field, bright and linear, and usually refuse to pivot around a single point that is itself in motion. Jaeger's pair does not behave like those cousins. The subtle sliver appears within a few arcseconds of the object in 2 adjacent stacks, then goes away when the phase angle and pointing change. When different observers repeat the cadence on other nights, nothing new appears, which is exactly what you expect if the geometry was briefly right and then quietly wrong. The streak is not proof. It is a hint whose personality is oddly consistent with a directed breath. What would a directed breath look like at this scale? In low thrust language, a plasma engine is a patient furnace. Gas is ionized and flung out at tens of kilometers per second. The reaction is real, but the glow is shy. Hall and ion thrusters in near-Earth space produce plumes that are faint, bluish, and tight to the body. At a distance of tens of millions of miles, and with apertures under a meter, the only thing you might see is a tiny elongation that hugs the source for a few frames when the exhaust vector points a little sideways to your line of sight. If the engine runs in pulses rather than a continuous stream, the effect becomes even easier to miss. Most nights, it would be invisible. On a few lucky alignments, the light would catch the breath for a heartbeat and then let it sink back into the black. The orbit fit does not care about color. It cares about timing. When modelers allow a small push that lasts hours near the night of Jaeger's frames, the residuals that bothered everyone become smooth enough to sleep. The ellipse of uncertainty rotates. The predicted corridor for a follow-up telescope shifts by a modest percent. A planned window on an instrument that cannot easily pivot becomes a poor bet. In round figures, the push needed is a few millionths of a meter per second squared, applied for a handful of hours. That buys a drift of thousands of miles a few weeks later. You do not need a torch to earn that. You need a thrifty nudge placed when leverage is high. The calendar bookmark in the fit sits within the same night that the small streak visited the pixels. 2 quiet notes, one in numbers and one in light, hum in the same key. Nature can still play this tune. A sun-warmed cavity can vent clean carbon monoxide or carbon dioxide without lifting much dust and make a brief, directionally tidy jet. If rotation is slow and the slit is tight, the thrust could remain steady for hours. The jet could graze the camera angle for a few frames and then slip outside the view. That is a respectable rival to the engine idea. It asks for a surface that filters grains and for luck with spin and lighting. It also asks for a tell that modelers can chase, such as a color change in a narrow filter or a coma that swells by a hair during the nudge. If repeated stacks stay clean and wideband colors stay plain, the jet needs to be both powerful and invisible in a way that makes patient minds squint. The more often the curve demands a push without a crumb of drift light, the more the natural nozzle starts to feel like a magician who never shows a fingertip. Grounded speculation lives between those two chairs. Imagine a control habit rather than a roar. Picture a guidance loop that prefers soft taps to long burns. On for 8 seconds, off for 12, settled into a duty cycle that the machine can tolerate for hours without heating itself into trouble. Such a rhythm would hide inside most cameras as a dim smear that only appears when the exhaust happens to point across the line of sight and when the stack aligns just so. It would also create a heartbeat that another instrument might hear as a whisper near a familiar communications band. If a distant probe once logged a narrow pulse near 1.44 gigahertz during a window that rhymes with our burn, the word coincidence can still be used. It is a sensible word. It is also a word that we place next to a tab where the residuals rotated on the same night. Let us be conservative about the hardware the sky could host without comedy. A sail that listens to sunlight could raise an area to mass and simulate thrust without expending fuel. That, however, tends to change the curve in a way that is smooth and always on, not in a way that looks like a timed push near a profitable geometry. A true engine is free to whisper only when it pays. A small thruster with exhaust speed around 30 kilometers per second running at a few kilowatts, could deliver the required push to an object with the mass of a modest mountain if it ran for a few hours. None of those figures are exotic. They are round and boring. The exotic part is not the power. It is the silence. A machine that hides its breath well enough to leave almost no light behind is either very good at collimating its exhaust, or it is choosing an exhaust that cameras cannot love. Charged particles that smear only in radio, neutral plumes that are too thin to scatter into glow. Either way, the numbers that drive the fit are comfortably ordinary, while the manner of the burn remains politely strange. The vivid picture is this: a dark stone glides in a lantern sea. For 2 frames, the stone grows a thin eyelash on one side, a thread that points away from the motion just enough to be noticed by someone who was not trying to prove anything. Then the eyelash is gone. The curve, however, keeps the memory. Weeks later, the appointment line on a space telescope's plan is missed by a small but stubborn margin. If someone were steering, this is exactly how they would do it. They would push early, when a small change buys a large future, and they would push gently when the sky is loud with other stories. They would avoid flames. They would avoid tails. They would leave a signature that only a handful of patient readers would bother to collect. There is an unsettling and honest question at the end of this file. If a trajectory burn has taken place, what turn is being prepared? Pilots favor leverage. They choose burns that set up the next meet. They use geometry to collect advantage, the way a saver uses interest. If this traveler is a pilot, or is guided by a law that behaves like one, then the nudge we think we saw is not the main act. It is a setup that moves a rendezvous, hides from a scheduled look, or lines up with a companion that passed through the field and then went quiet. In the next chapter, we open the folder named V1. It arrived near the time the curve began to lean, then slipped, and then left the rumor mill chasing its shadow. If there was a key that turned the lock on this new acceleration, we will ask how it fit, and whether the lock it opened was a target rather than a door. It appeared like a footnote written in fading ink. A dim point, a few arc minutes from 3I, logged by 3 small observatories on a cold run and labeled with a working tag that sounded provisional and familiar at the same time. V1. The surname offered in some emails made old readers blink because a comet named Borisov has visited our century before, a true interstellar wanderer with a classic veil. This V1 was something else. A stray that arrived near the hour our curve began to lean, then slipped off the docket as if the sky had swallowed it. The thread is thin, the timing is thick. If a key existed, this is where a hand would have turned it. Begin with the anchor we can stand on, without wobble. Observers lose new objects when arcs are short and magnitudes sit near the edge of modest glass. A body that lives around magnitude 20 can vanish when clouds move, or when the ephemeris gathers one wrong assumption and slides away by a handful of arc minutes. Catalogs have gaps. Background stars complicate subtractions. This part is ordinary and kind. It explains why something dim could appear in 3 notes, then fall off the schedule when nights were scarce. There is nothing conspiratorial about a misplaced point in a crowded sky. The mystery would end here, except for the rhythm that ties V1 to the hour when the fit improved only after we allowed a fresh push. The alignment does not prove intent. It does invite a different kind of patience. The patience belongs to rendezvous math. In the quiet language of celestial mechanics, Small bodies meet to trade energy or information without drama. Gravity assists are common. So are shadowed flybys that change orientation or test sensors. None of this requires noise. A close pass a few hundred kilometers wide would be invisible to most cameras and yet powerful for timing. If V1 passed behind or beside the 3I for a few minutes, the geometry could have provided a star field that a navigation system could use to reset. It could have offered a reference beacon if V1 carried a bright patch that flashed in a known rhythm. It could have seeded a surface with a volatile patch that would vent in a controllable way when warmed. Those are grounded speculations that do not demand a grand machine. They are the kinds of favors small worlds give each other when they pass and leave no headline behind. There is a second anchor worth laying on the table. The hydrogen line sits near 1.42 gigahertz, a simple frequency that radio astronomers love because neutral hydrogen whispers there. The number that keeps returning in rumors about a distant probe's note is 1.44 gigahertz, which is near enough to feel like a cousin while being far enough to avoid crowded pipelines. If a device wanted to speak in a place where many instruments already listen, it would sit in that neighborhood. If two bodies wanted to test a handshake, they would prefer a band where a brief tone would blend with honest sky noise. The claim is still a whisper. We file it as a coincidence that is convenient and keep the word coincidence within reach. We also underline the night it is said to have occurred. The same week the curve asked for a push, the same week V1 came and went. The vivid image is simple and does not try to impress. Two dark stones share a quiet corridor. For a short while, their paths overlap just enough that a sensor on one can see the other's brightness slide across a grid and measure a drift. A metronome ticks. 8 seconds alive, 12 seconds sleeping. The metronome lives not to shout through space, but to keep a loop inside the hardware honest. A compass keeps its temper, an attitude wheel holds its promise. When the short pass ends, the darker stone proceeds with a fresh sense of where it is pointing. Hours later, as the geometry with the sun sweetens, a push begins that lasts just long enough to rotate the future path by a modest percent. To most eyes, the night is unchanged. To a fit that cares, the nudge is a hinge. The naturalist in us wants a different story and deserves a fair hearing. V1 could have been a near-Earth object that drifted through the same frame by chance and then fell below the floor before anyone could collect a longer arc. It could have been a star that masqueraded as motion in a bad subtraction and then resolved once the stack improved. It could have been real and unconnected, a stranger that wandered past while 3I prepared its own unrelated change in speed for reasons that belong to pits and ledges and clean gas. These alternatives are healthy. They keep us from building a tower out of a few uncertain bricks. We are free to carry them along as control cases. We are also free to point out that the dates continue to rhyme in a way that refuses to be boring. Here is the imaginative leap, set down with care. Suppose V1 was not an engine, but a key, because it carried the pattern needed to unlock a mode on 3I's driver. Many systems will not act until a handshake is confirmed. A short-lived visitor could provide that handshake by reflecting a simple code in a familiar band or by presenting a known light curve at a known rate across the sky. Once the code is seen, a lockout clears and a guidance loop permits thrust. The object does not need to be captured. It does not need to be consumed. It only needs to pass with the right timing under the right stars. After that, the rest of the job belongs to a thrifty burn that prefers not to glow. The lack of a tail is not a failure, it is the point. There is a way to test this picture without chasing ghosts. If a key turn took place, we should see a behavioral change that begins within a small window after the pass. The change does not need to be large. It needs to be consistent with a guidance system that has accepted a new target or a new frame. In practical terms, the uncertainty ellipse should rotate. The predicted windows for follow-up should slide just far enough that a team relying on yesterday's plan will miss a look by a careful margin. Subsequent residuals should become smoother when a low-duty cycle push is added to the model. These features have been observed in other contexts, including small spacecraft that perform station keeping in near-Earth space. The difference here is distance and silence. The same rules live far from home if the pilot is patient. A quiet aside returns us to the rumor of a Mars camera that did not share a frame on a night that now sits inside our V1 window. Mars reconnaissance is famous for its discipline. A withheld product attracts attention even when the reason is mundane. There are countless reasons to delay a single image, from compression artifacts to boring calibration faults that take time to audit. The polite explanation is usually correct. Yet it is difficult to ignore the possibility that an instrument pointed into the right corridor might have seen more than dust. Hardware outlines, bright pins that do not match random surface glint, features that look like arrays or nozzles when you trace their edges too long. If an agency wanted to avoid wild interpretations during a week when the file was already itchy, the simplest move would be to take a breath and post later. Delay is not proof of concealment. It is consistent with a policy of not feeding anxious eyes while a larger review is underway. We close this file with a question that does not raise its voice. If V1 acted as a key, what door did it unlock? A rendezvous mode, a firmware gate, a thermal practice that needed a reference before it could settle into a safe duty cycle. Any of those possibilities points toward intention without demanding menace. The aim of a key is not to frighten, it is to enable control. Control is the heart of the pattern we are tracing. A soft pass, a metronome and a friendly band, a push that starts on schedule and hides inside the honest noise of a busy week. The next section turns fully to the photographs and the way institutions behave when single frames threaten to rewrite an official story. We will lay the MRO delay beside the calm numbers and ask why the most ordinary response to an extraordinary hint is often silence. The rumor has both a date and an orbit. Mars turns like a quiet librarian, and the Mars Reconnaissance Orbiter glides above the stacks with a camera that remembers footnotes. Most days the shelves are open, a dust devil is cataloged, a cliff is filed, a dune shifts and finds its label. Then a page fails to arrive. A request that should resolve into an image returns a placeholder and a polite procedural note. Review pending, calibration in progress. The red planet keeps rotating while somewhere in the pipeline, a single frame waits behind a gray door that normally opens without ceremony. Sleepy readers glance away. Patient readers mark the time. The object that concerns us keeps moving. The hard facts are calm, and we set them down first so the mind can rest. Spacecraft do not post directly to the public. Data falls in bursts through deep space dishes, is checked for blanks and spikes, and is sorted by time, target, and instrument mode. Some products drop cleanly into the archive within hours. Others need a day or two of careful rework. Glitches are common and unromantic. A radiation hit can salt a detector. A buffer can hiccup. Compression can stutter. A clock can wander, while the flight computer shrugs and keeps following its plan. Archivists dislike drama. They correct, confirm, and only then release. A single hold is not a scandal. It is part of the hygiene that keeps big machines honest. Still, the lore writes itself when a hold lands in the wrong week. A file name begins to circulate on quiet lists. A thumbnail refuses to render. A planning note mentions an off nadir look that matches a thin strip of sky and a time already circled in another file. The frame does not have to point at Mars to matter. High-resolution imagers sometimes look outward to tune focus or measure smear. Navigation heads always look outward. Even a spare star field becomes a clue if it sits inside the same corridor where months and millions of miles away, another instrument once heard a narrow whisper. When calendars rhyme, the mind underlines. Begin with conservative reasons that might place a lock on a harmless scene. Dust on optics can masquerade as structure until flat field maps correct it. A seasonal haze can brighten the limb and force a rewrite of gain tables. The spacecraft can drop briefly into safe mode and then climb back without drama, leaving partial files that look like riddles until the gaps are patched. A reviewer can simply ask for a second look before posting, because once a frame enters the public record, it begins to live its own life in other people's hands. Most of the time, the boring explanation is the true one. Most of the time, a delay is a nap, not a plot. Now open the Boulder folder with steady hands. Imagine a long, narrow strip that skims the dark near the night side, not at terrain, but through the sky beyond it. Against that velvet sit 2 or 3 points that refuse to smear like stars when the spacecraft jitters. Their edges look coaxed, not rounded. One point throws a brief knife of light that holds the same angle over a handful of lines, as if reflecting off a narrow lip. In a lab, you might call it a nozzle. In a meeting, you would call it an artifact, until you were forced to pick a stronger word. No trumpet, no tail, just a hard geometry that does not behave like dust or rock. If such a frame existed, the quiet choice would be to pause, to let engineers argue under closed lights while the calendar outside keeps churning. Institutional silence is not a cape. It is a workflow, a communications calendar that budgets one update a week cannot easily narrate a half-understood picture without inviting noise. Legal teams prefer words like routine and nominal. Flight teams prefer not to be quoted while they are still testing a hypothesis. The result, viewed from the outside, feels like secrecy, and from the inside, feels like hygiene. In a week when the sun is loud and airlines and grid operators need attention, the least risky course is to speak softly or not at all. You do not feed speculation while you are still checking whether a bright edge is a reflection, a hot pixel bloom, or the outline of something with corners. There are ways to test the edges without turning the story into accusation. Watch the cadence of releases for gaps that do not match holidays or planned maintenance. Note labels that say reprocessed with updated calibration, and see whether the acquisition date sits far behind the publish date in a way that is unusual for that instrument. Compare sequence numbers of neighboring frames and record if one is skipped and later inserted with a different suffix. Overlap these dates with the nights when the orbit fit required a new non-gravitational term to settle. If the same window holds both a rotated covariance ellipse for 3I and a delayed posting from a skyward glance near Mars, the evidence does not shout. It hums in unison. A vivid picture helps the mind hold the thread. Picture Mars below like a red coin, and, off the coin's edge, a deep velvet where the stars hang. The camera skates that border. In most lines, the stars trace soft slants that match the spacecraft's swing. In a handful of lines, a point resists the smear and keeps a hard edge. A second, smaller glint sits at a spacing that would make a guidance engineer pause. 3 times that span, the larger point grows a faint eyelash that leans away from the sun at an angle that matches the push our fit prefers. To almost every eye, this would be nothing at all. To a tired analyst on a late shift, it would look like maneuverability writ small, not a plume, a hint of hardware. Grounded speculation asks why such a frame would be awkward to release, even if the team suspects it is nothing. The answer is reputational gravity. Once a public image is read as engineered, it becomes a banner for any theory that wants a banner. Corrections almost never catch the myth. A modest delay avoids that loop at the cost of seeding a different rumor. Agencies have learned this the hard way. The calculus is simple and a little cruel. Post now and spend weeks answering questions about engine outlines and flight paths, or wait, check, and risk feeding a quieter story about what was not shown. In either case, the orbit fit keeps its own counsel. The numbers accept or reject a push independent of press schedules. Here is the imaginative bead we place on a string of plain facts. Suppose the strip did not only show a glint. Suppose it showed alignment. 2 persistent pins and a third echo whose spacing matches a 3-point attitude cluster that could keep a nose steady while a gentle burn accumulates. Reflection angles would not prove a thruster. They would suggest edges. Edges suggest hardware. Hardware suggests control. Control explains why the orbit fit slept only after we allowed a timed push. The closing question is quiet and sharp. If an image near Mars hinted at capability rather than color, what would the public have been invited to infer about 3I's new behavior? In the next file, we will ask why anyone would choose to hide not the hue of a frame, but the proof that a small dark traveler could steer. They did not hide a color, they hid a capability. That is the quiet thesis you reach when you set an ordinary delay beside an extraordinary week and watch how curves and calendars hum in the same key. Agencies do not blink at dust. They blink at edges. A blue tint invites comments. A repeated geometry invites risk. If a frame hints that a small traveler can change its own future on command, the problem is not image processing. The problem is meaning. Meaning moves markets, policy, alliances, and the delicate story an agency tells when it wants wonder without panic. Workflows give the pause a home. A mission keeps a posting cadence. A release board meets on Thursdays. Legal checks nouns. Engineers check histograms. Public affairs drafts 2 paragraphs that repeat the right verbs. Routine. Nominal. Inside that ritual, you can place any single photo under review without breaking the machine. Most weeks, that is responsible. In a week when the orbit fit for 3, I softened only after a clean low-duty cycle push was allowed, and when a narrowband rumor near 1.44 gigahertz reappeared in a logbook no one expected to matter, routine begins to feel like a shield. You do not need a plot to create silence. You need a checklist and a reason to be careful. Hard facts keep us honest while we consider motive. Mars reconnaissance works. For years, it has returned sharp lines and faithful shadows. A high-resolution camera sometimes looks off-planet for focus checks, smear tests, or star field calibration. Those modes are routine. They produce strips where the planet is a rim and the sky beyond is velvet. In such strips, stars smear in directions that match the spacecraft attitude history. Anything that holds a clean edge while the field leans becomes interesting. If a point resists the smear across multiple lines, or if a second point keeps a measured spacing that matches a rigid frame, the picture stops being pretty and starts being mechanical. The hazard is not beauty, the hazard is inference. The grounded speculation is narrow and testable. If a withheld strip contained two persistent points with spacing and symmetry that match a stable platform, plus a faint eyelash at an angle equal to the thrust vector favored by the orbit fit, the image would act like circumstantial proof of maneuverability. Not a portrait of a ship, not a glossy drama. Just three numbers that line up across the independent files. Angle, spacing, timing, none of those are sensational. All of them are dangerous to a simple narrative that treats 3I as drift that can be scheduled. A single frame that hints at control would force new words into public captions and invite questions that a cautious office is not prepared to answer in a week of loud headlines. So why hide it? Because images shape the public mind faster than plots. Most viewers cannot read a covariance ellipse. They can, however, stare at three bright points and a sliver and decide that something with corners is steering. That conclusion may be wrong. It may be right. Either way, it is hard to dislodge once it lands. Agencies do not wish to manage folklore. They prefer clean updates with low drama and high confidence. In that culture, a delay is not deception, it is risk control. You buy time to reprocess the strip, to compare it against bias maps and flats, to ask whether the eyelash is an internal reflection or a line of charge. You also buy time to decide how to keep the conversation tethered to physics when the week already carries stems and noise. There is also institutional memory. Every agency remembers the cycle where a stray pixel became a headline and a headline became a hearing. The fix took minutes and the rumor took months. That experience leaves a mark. It writes a policy that says, do not feed ambiguous geometry to an audience trained by fiction to see machines in noise. Calmer still, it writes a second policy. If a frame does show a geometry that is hard to dismiss, do not invite a guessing contest while teams downstream compare it to independent evidence. Crosslink first. Announce later if an orbit fit and a calibration strip and an offhand radio note begin to rhyme. The safest public word is review. Let the imaginative leap be small but sharp. Suppose a withheld strip did not simply hint at edges. Suppose it lined up with a short parade of other cues. A faint plasma thread reported by a careful amateur on a night that later proved profitable for a burn. A duty cycle in radio that a distant probe logged near a band where many ears already listen. A planning note that moved a follow-up window from a confident hour to a tentative one after the fit accepted a new term. None of these alone would require a lock. Together, they would make a picture feel radioactive in the public square. You would protect the analysis by lowering the temperature. You would protect the team by giving them days to test the eyelash against every innocent cause before you let the image breathe. The vivid image is quiet. Picture a meeting room with tired eyes and cold coffee. On a screen, a narrow strip shows Mars as a rim and the black beyond. Someone toggles a stretch. 2 points hold their edges while stars smear. A tiny eyelash leans away from the sun at an angle that matches the number on a separate whiteboard. No one says the word nozzle. No one needs to. The conversation is about whether the camera or the tube could have made this by itself. It is about whether a bias map missed a seasonal change. It is about whether a safe mode splice could have built a fake edge. When those answers do not satisfy, the room becomes very still. The capability implied is not speed, it is aim. Now translate that room into public language. The release will not say engine, it will not say steering, it will say reprocessing, calibration, review. Those words are not lies, they are buffers. They are what you say while you check crosslinks and decide how to keep the conversation tethered to physics. Outrage is unnecessary. Acceptance is enough. Images are accelerants. Institutions prefer to pour water, not oil, on a landscape that can catch fire. The correct path for them is to slow the feed and widen the gap between rumor and record. In that gap, they hope the storms will claim the spotlight while the numbers find a sober home. Here is the unsettling question that remains after you subtract workflow and caution. If the delay hid capability rather than color, what capability was judged too potent for an ordinary caption? The alignment of points that implies a rigid structure, the hint of an exhaust that implies reaction mass or charged particles, the implication that a small traveler can aim. Each possibility narrows the list of futures for 3I. Each pushes the conversation away from harmless drift and toward target and intent. That pivot is what institutions are not ready to host in a week of solar weather and fragile nerves. Which brings us to the next file. If you cannot erase capability, you shape the narrative that surrounds it. You set the terms of the public debate. You seed calm phrases, and you let trusted voices argue the edges while the guidance continues in the dark. We will open that information war next and measure how softly a story can be steered. The first sound in any crisis is not the alarm. It is the voice that decides what the alarm means. Picture a newsroom washed in cold light, a producer circling words on a whiteboard, an agency spokesperson on a headset promising a tidy quote in 20 minutes. Outside, auroras rush the poles and feeds fill with emerald curtains. Inside, the script is assembled. The lines are gentle and familiar, routine, nominal, reprocessing. A debate panel is booked before dinner. Two famous scientists with opposite styles say their careful pieces on motion and meaning. The audience hears confidence. The file hears choreography. Hard facts set the frame. Agencies carry communications calendars that run like machines. Press advisories are drafted days in advance. Review committees meet on fixed slots. Talking points are cleared across internal channels so no one wanders off script. Peer review for real anomalies takes months. Public remarks arrive within hours. That mismatch creates a natural pressure to use placeholder language until analysis catches up. There is nothing sinister about a sentence that says calibration in progress. It is simply the safest line when a picture or a plot is not ready for technical scrutiny. The trouble begins when many small placeholders begin to move in the same direction and land in the same week that an orbit fit demands a new push term. Pattern is what the public feels before it measures. Call the next layer by its plain name: narrative management. When a story can tilt markets or shift attention, institutions steer toward frames that minimize drama. They pick validators with known temperaments. They encourage a friendly argument over harmless questions, such as whether an object is a comet or an asteroid, while the harder question of control waits behind the glass. The science in these exchanges is real. The gravity in them is social. The point is not to lie. The point is to place cushions around meanings that are not yet convenient. You see this in the vocabulary that repeats across agencies and weeks. Anomalous becomes unusual. Engine becomes non-gravitational term. Steering becomes trajectory solution update. The public exhales. The file grows teeth. Set two voices on the table as a study in contrasts. One voice is polished and protective. It says extraordinary claims. It asks for restraint. It reminds us that outgassing can be dustless and that sales can be natural. It is not wrong. It is also a comfort. The other voice is provocative and restless. It asks whether an absence of tail paired with a persistent push deserves language closer to propulsion. It points to timing. It questions why fit windows slide after quiet weeks. Neither voice is the villain of this story. Together, they create a corridor down which a larger institution can walk. While the public measures the debate, schedule changes pass quietly, and a single withheld strip waits behind a review badge. The theater is calm, almost sleepy. The choreography is better than the lighting. The hard science anchor stays in view, so we do not drift. Non-gravitational acceleration is not a rumor. It is the very term that orbit fitters use when gravity and sunlight are not enough. Solar radiation pressure is not a ruse. It is a pressure we can calculate with round figures. Sublimation through vents is not a fantasy. It is a measured behavior on many comets. These anchors keep our feet on the floor. The grounded speculation lives in how these anchors are presented. When every podium selects only the mildest explanation, even as residuals smooth only after a timed push is added, a skeptical mind notes the asymmetry. The facts are allowed. The implications are soothed. Now apply the quiet tactic that matters most in an information war built for a sleepy audience. Flood the channel with adjacent truth. Space weather dashboards refresh every few minutes. Airline advisories scroll. 1,000 photographs of aurora sail through the feed. Explainers on geomagnetism and transformer safety arrive in long threads. These are useful and responsible. They also create a sound that drowns a smaller rhythm. In that sound, a modest update appears about an interstellar object. The update says the solution set has been revised. It offers a new corridor. It does not mention the small sustained push that made it necessary. By the time a patient reader arrives at that line, the page has already taken their breath with lights over Iceland and with maps of safe polar routes. The steering idea survives in quiet margins only. The imaginative leap is small and measured. Suppose this flood and framing are not reactive only, but opportunistic. The storms are real and deserve attention. The earthquakes are real and deserve care. A communications team does not invent them. It uses them. It recognizes that a week where eyes point downward is a week when a skyward nuance can be filed without a crowd. In that window, you can delay a strip that hints at edges. You can rotate a fit and reschedule a follow-up. You can book a debate that keeps the public inside safe nouns. You are not hiding the sun. You are shading a candle. The tactic is not panic. It is patience. The vivid image returns to the meeting room where language is chosen. A small group studies 3 clippings on a wall, a transcript of a televised exchange where one expert says drift and the other says driver. A planning note that moves a telescope window by 2 days. A technical memo that lists a narrowband tone near 1.44 gigahertz, captured during a pass that few people remember. None of these items make a headline alone. Together they outline a story that would be hard to host on a calm Friday. The decision is to speak softly, to let the debate carry the weight, and to leave the technical memo in a drawer marked internal until someone else forces the subject. The memo is not erased. It is simply not yet. Here is the question that keeps its voice low and steady. If the argument that we are allowed to hear is about labels, what argument is taking place where we cannot? A capability argument is the most likely candidate, aim versus drift, schedule versus prediction. If the capability is real, even in a modest form, then the next move belongs to a different set of files. Telemetry that does not fit a public archive. Timing notes that rhyme across agencies. A pulse that repeats near a frequency where many ears already listen because the universe itself hums there. In the next chapter, we open the folder that carries that whisper. The entry line says leak. The content describes a rhythm. The number is simple enough to remember when you close your eyes. The leak did not arrive as a headline. It arrived as a thin, pale line on a spectrogram, a whisper traced by a tired hand under fluorescent lights. A technician at a European ground station logged a narrow tone near 1.44 gigahertz during a routine pass. The note drifted in for a few minutes, held a steady rhythm, and then folded into the ordinary hash of space. No stamp said classified. No stamp said real. What the note had was timing. It shared the same week when the fit for 3i softened only after a low, steady push was added. In a room where schedules are printed in rounded blocks of 15 minutes, the coincidence drew a slow breath. Let the hard frame go down first, so we do not float. Spacecraft radios live in assigned bands. Ground arrays listen across swaths that include familiar beacons and unwanted clutter from Earth. Receivers use local oscillators, mixers, and gain stages that can cook up harmless ghosts if you are not careful. A narrow tone near 1.44 gigahertz sits close to the hydrogen line neighborhood where radio astronomers spend long nights. It is not special by itself. It becomes interesting only when it repeats at a cadence that looks deliberate, and only when that cadence appears during a window where a spacecraft geometry is already under review for unrelated reasons. A single sketch in a lab notebook is nothing. A sketch whose clock face rhymes with a different file is something you circle and set aside. Begin with the innocent suspects, because most mysteries dissolve under their light. Ground interference loves L-band. Cell towers, telemetry from weather balloons, harmonics from local gear, even a hurried technician's laptop can draw lines where none belong. A reflection off a passing aircraft can create a short, misleading tone that seems to come from the sky when it is only bouncing off aluminum. Receivers drift if they are not warmed. Filters ring if a strong neighbor leaks into the passband. The clean way to treat the 1.44 whisper is to assume error and then try to break that assumption, not to assume intent and chase it with excitement. Interference checks, cross-station comparisons, and time-aligned replays are the sober tools. Now set the rumor back on the table with those tools in hand. The spectrogram shows a tone that rises by a hair, falls by a hair, and repeats in a way that draws steps like a heartbeat rather than a siren. The rise time is short enough to look like a switch. The dwell is long enough to look like a usable interval, and the cycle repeats at a period that lives comfortably within 10 seconds. The segment lasts a few minutes, stops, and then does not return for the rest of the pass. A separate station, a few hundred kilometers away, logs a faint trace of the same ladder without enough strength to be a clean duplicate. That second trace could be imagination. It could be real. In files like this, reality often moves just 1 inch ahead of confidence. Hard science lets us anchor the cadence to plausible machines without promising any. Low-thrust engines that fling ions or accelerate plasma like regular schedules. A controller prefers on for a few seconds, off for a few seconds, so heat can bleed and grids can rest. Telemetry systems sometimes mirror that rhythm because engineers want to see a short status burst synchronized to a pulse. If a beam leaks or a harmonic leaks while the engine breathes, an outside ear might catch a periodic tone that has nothing to do with communications and everything to do with housekeeping inside a black box. The period is the tell. A random tone drifts. A duty cycle repeats. A duty cycle that matches the few seconds on, few seconds off implied by a slow, accumulated push is where sober minds lean forward. Grounded speculation asks whether a distant probe like JUICE could be an accidental microphone for such a rhythm. It carries radios that speak in clean, licensed bands. It also sits inside a river of radio where Earth, Sun, and local equipment paint the spectrum with predictable patterns. If a traveler near the line of sight pulsed a field that nudged charged particles or bled a narrow internal oscillator, the mix of reflections and intermodulation could produce a faint, periodic trace at a safe remove from the probe's official channel. An engineer would call this contamination and reach for a calibration sequence. A storyteller would call it a metronome and reach for a notebook. We are allowed to admit that both reactions can be honest at the same time. The vivid picture is plain. A spectrogram looks like a winter city seen from above, blocks, streets, and the weak glow of traffic. In one district, a single streetlight clicks on and off with the patience of a metronome. 8 seconds bright, 12 seconds dim. The light runs for a few minutes and vanishes. On a different wall, a plot of residuals for 3I changes character on the same night only when a smooth, low acceleration term is added for just a handful of hours. In a drawer marked pending, a narrow imaging strip is still being reprocessed after a planning note showed an off-nadir look into the same corridor. None of this is proof. Together, it is a melody played on 3 instruments that did not plan to be a band. The imaginative leap, set down gently, is that the 1.44 rhythm is the engine's voice rather than the radio's message. Not a call meant for us, but a housekeeping tick meant for itself, bleeding into the spectrum as a side effect. A machine that swallows propellant or pushes charges would want to count. It would want to space its heat. It would want to open a valve, accelerate a plume, rest, and repeat until a target delta V arrives. If that count lives near a frequency where many ears already attend to the cosmos, its footprint would hide in plain sight. Excused as astronomy, unless timing nags someone to look twice. The leak is not a confession. It is an overheard rhythm. There is a sober way to test this picture that does not require belief. Align timestamps. If the tone appears within a window that also delivers a small rotation of the uncertainty ellipse for 3i, if the duration of the tone matches the hours-long push the fit prefers, and if the cadence sits in the range engineers choose to manage heat and thrift, then the most conservative sentence available becomes difficult to avoid. A periodic process ran near the line of sight during the same window when the orbit solution improved only after a gentle acceleration was allowed. Periodic does not equal propulsion. It does, however, make propulsion a patient suspect rather than a dramatic guest. The question to carry forward is not whether the leak is real in the tabloid sense. It is whether the rhythm, if real, belongs to a physics that can move a small body without a tail. If the answer is yes, then the pieces begin to order themselves. A withheld strip hints at edges rather than color. A calm debate steers public attention toward harmless labels. A narrow-band ladder taps a count that a machine might use to stay cool while it turns. The remainder lives in the simplest place of all, the numbers. In the next file, we will put the pulse beside the acceleration directly, ask for their overlap, and measure whether the ladder of seconds can be heard again in the way the sky's pencil line bends. We set the pulse beside the bend and let them breathe in the same room. On one screen, a spectrogram shows a faint ladder near 1.44 gigahertz, steps that rise and settle on a patient rhythm. On another screen, the orbit residuals for 3i smooth only when a small, hours-long push is permitted. Neither chart shouts. Both persist. If you nudge their clocks into the same frame, allowing for light time, station delays, and the slow drift of spacecraft schedules, their edges begin to rhyme. A heartbeat in radio, a slow lean in the sky. Two instruments, two languages, one sentence whispered twice. Hard facts first, so the mind can rest. The added acceleration is small and polite, a few millionths of a meter per second squared, applied for only a handful of hours. The effect is local in time and large in consequence, shifting prediction windows by rounded percentages days later. The tone sits in a neighborhood many ears already watch. Near 1.44 gigahertz, narrow lines are not exotic. What is unusual is a stepped cadence that repeats on the order of 10 seconds and then halts. Neither number is dramatic. Both are consistent with a low-duty cycle process designed to manage heat and thrift rather than spectacle. We align clocks with the care a navigator gives a sextant. Time stamps slide to coordinated universal time, then to a barycentric frame, so the sun's own gravity does not tug our comparisons. Light time corrections remove minutes in transit, so events share the same now. Receiver logs give us station latitudes and temperature drifts. Spacecraft planners' notes give us antenna states and pointing habits in rounded 15-minute blocks. When we overlay the pulse window on the fit that prefers a push, the overlap is not perfect. Real files rarely are, but the intersection is stubborn. A few minutes of heartbeats live neatly inside a few hours of gentle acceleration. The math is gentle, and it keeps us honest. We do not claim a discovery. We ask a question with a cross-correlation that slides the pulse train across the time derivative of the residuals and measures how often their rises and rests move together by accident. Then we break the answer on purpose, shuffle the pulse spacings, mirror the train, inject synthetic interference, and watch the correlation collapse toward ordinary. When we put the original pieces back, the lift returns. It is not a festival, it is a quiet bias that resists being washed away. A statistician would call it suggestive. A flight engineer would call it actionable enough to check again tomorrow. Nature argues her case with grace. A jet tied to rotation can mimic a metronome if the spin is slow and the vent geometry is tight. 10 to 20 seconds is not absurd for a tumbling shard with an odd body frame. But a rotational metronome brings friends. A color change in narrow filters, a coma that fattens by a hair, a periodic brightening that drifts with phase angle. The stacks we have are spare. The profile stays clean. If a vent exists, it behaves like a scalpel and hides its scraps. That is possible. It is also a demand. Precise spin, precise slit, precise lighting, repeated luck. When a natural model asks for that many small favors, it remains in play, but cedes some ground to rival explanations. The machine hypothesis does not require grandeur. It asks for control logic that counts. A low-thrust drawer opens a valve for 8 seconds, accelerates ions or heated neutrals, rests for 12 so grids and chambers can cool, and repeats until the target delta V arrives. The controller can keep its own time with an oscillator whose faint harmonic leaks into a band crowded enough to hide it. The radio voice is not the message, it is the breath behind the message, a side effect that only shows up when geometry and gain cooperate. In that picture, the pulse is the metronome, and the bend is the dance. Neither is theatrical, both are deliberate. Hold a single image while the numbers settle. Imagine a pendulum ticking in a dim room while a pencil line on the wall leans 1 degree in one long evening. You would not notice the angle if you were busy. You would not hear the pendulum if the street were loud. But in the quiet, they belong to each other. Each tick marks a breath of effort. Each breath accumulates until the lean matters. That is the scale we are dealing with. Seconds as ticks, hours as effort, weeks as meaning. It is a scale built for calm work, not for crowds. Grounded speculation suggests an operational logic that prefers cover to applause. If you were the pilot of Thrift, you would time pulses to windows, where receivers are busy with honest storms and planners are busy with airlines and grids. You would start the sequence late in a pass, so only a few minutes rise above the floor. You would place the run in a geometry that turns centimeters per second into thousands of miles of future drift and lets you miss an appointment you no longer wish to keep. The rhythm we saw lives inside those simple rules. The fit that improved lives there too. It is not a thriller. It is a budget. The imaginative leap is small and sharp. The 1.44 ladder is not aimed at us. It is an internal metronome bleeding into our ears. That metronome governs a field or a flow. When it is on, the driver pushes. When it is off, the driver cools. The orbit absorbs the difference, the way a slow river absorbs a pebble's ripple. If we are right, the radio trace will not always be audible. It will show up only when geometry and gain align, only when a ground station's window intersects the quiet hours selected for thrift. But the orbit will remember every tick, whether we hear it or not. The question we carry forward is polite and unsettling. If the rhythm marks the push, who arranged the perfect background music? Solar storms filled the room with sound. Headlines kept eyes on Earth. In that cover, a small object appears to have counted seconds and bought a new future with heat and patience. We will not accuse the weather of being a curtain. We will ask whether it became one. In the next chapter, we place the pulse and the push in the context of the week's noise and examine how a perfect smokescreen can exist without a single conspirator lifting a hand. The week became a soft storm of attention. Maps of aurora slid across late-night screens. Airline trackers showed long arcs that avoided the poles. Grid operators posted careful notes about transformer load and voltage control. On a different channel, a panel spoke in comfortable phrases about what the sun was doing and why the Earth would be fine. In that long, hushed broadcast, a smaller story could travel without company. If a traveler intended to change its future, this was the kind of weather that would let it work in peace. Not because the sky had a plan, but because crowded rooms listened to the loudest sound first. Set a few calm facts on the table, so our minds have weight. Solar activity rises and falls on a cycle that averages about 11 years. Strong flares can lift clouds of plasma that hurry outward near 1,000 kilometers each second. Airlines that cross the poles sometimes step south to avoid radiation and communications trouble. Power companies keep an eye on currents that creep in long wires during space weather. None of these choices require mystery. They are the ordinary professional responses of a planet inside a changing wind. The unsettled ground beneath our feet follows a different clock. Faults slip along old scars. Studies that hunt for a reliable trigger from space return mixed or weak results. The near-term rhythm of quakes does not answer to storms in the solar wind. A perfect smokescreen does not need an author. It needs only a week where honest tasks grow louder together. During that week, the attention economy bends toward home. The stories are real, the images are striking, and the work is important. A small signal that belongs to a dark body outside the headlines can live under that canopy and not be lonely. It is not that anyone is hiding a thing behind the weather, it is that weather fills the room. The rest of the conversation chooses a smaller voice. Opportunistic camouflage is a property of timing, not a crime. Now place our quiet files inside that room. A narrow ladder near 1.44 gigahertz ticks for a few minutes and stops. An orbit solution softens only when a low acceleration is allowed for a handful of hours. A planned follow-up window slides by a careful margin after a new corridor is posted. A calibration strip is said to be under review long enough to skip a cycle. None of those acts shout. Together they act like a hand putting soft tissue around a bone. The shape that emerges is not speed, it is control. The timing is not theatrical, it is thrifty. Ground truth in operations looks like this. A scheduler moves a line on a plan by a day to protect a higher priority target. A telescope that cannot pivot quickly loses a look and waits for the next chance. A deep space antenna that was going to track one object keeps the same time slot but points a few degrees away. An analyst who finds a drift in residuals writes a one-line note that says a non-gravitational term improved the fit during a particular window. No drama, many clocks. When storms fill the feeds, none of these adjustments rise above the floor. The work is still done, the map still changes, the public squares stay busy with other pictures. Hold a single image and let numbers join it without fuss. Over Greenland, the sky glows green and violet, while a pilot edges a flight path south by a few hundred miles. In a quiet lab, a spectrogram shows a heartbeat that repeats about every 10 seconds, then leaves. In a separate room, a pencil line that was supposed to be a perfect conic leans by a breath once a few millionths of a meter per second squared are added to an overnight fit. Hours of steady effort by thousands of miles of future drift. The arithmetic is tidy and small. The consequences are large and late. The imaginative step is slight and careful. Suppose a pilot, or hardware that behaves like one, prefers to move inside noisy weeks. Not to cause them, but to nest inside them. You would choose windows that cover your duty cycle with other news. You would avoid long burns that print a bright signature, and you would prefer pulses that manage heat and hide in the floor of most cameras. You would stack those pulses where geometry turns centimeters per second into skipped appointments later. That is not malice. That is craft. The camouflage is the world paying attention to something it must already do. There is a second layer, and it belongs to words. When the stage is full of space weather explainers, it is easy to keep the public script inside safe nouns. Drift instead of driver, unusual instead of engineered, calibration instead of capability. Two respected voices can disagree about labels, which is healthy, while schedules and fits change without fanfare. That is a gentle information war. No lies, many cushions. It keeps nerves quiet, while teams that need time get time. It also leaves a question standing in the doorway for anyone who watches the clock and the curve at once. If a traveler counted seconds during that noisy week, what appointment did those seconds buy? We can close this section without heat and still leave a hinge for what follows. The storms did real work. The planet stayed steady. In that cover, an object appears to have chosen thrift and patience. A pulse became a plan became a shifted corridor. If capability was the thing an image threatened to show, then intent is the thing that our numbers now begin to ask us to name. A careful hand does not nudge without a destination. It leans because a meeting waits. Where and with whom and under what shadow are the questions we carry into the next room? The title of that room is simple enough to whisper as the lights go lower. Target lock. Settle your shoulders and picture a classroom with the lights turned low. Chalk dust hangs in a sunbeam, then drifts away. On the board, there are 3 small words that have carried too much weight in the last few years. Non-gravitational acceleration. They sound like a magician's phrase, but they are not. They are the label we use when gravity and sunlight alone cannot close the books on a path through space. Tonight, the lecture is slow. We are going to walk through the ordinary ways a small body can move without lighting a torch, and we will keep the numbers round enough to sleep. The goal is not to dazzle. The goal is to recognize which tricks leave footprints and which tricks leave almost none. Begin with the gentlest engine of all. Sunlight pushes. Near the orbit of Earth, the pressure from photons sits around 10 micronewtons for each square meter of surface. Say that number again the sleepy way. 10, not 10,000, not 10 million. 10. If you carry a sail of 100 square meters and build it from a film as thin as a whisper, the push is about 1,000 micronewtons. That sounds like nothing until you let it work for hours and days. A few millionths of a meter per second squared becomes centimeters per second in a week and kilometers per hour in a month. The trick is not power. The trick is patience. Sails like Icaros and Light Sail prove the principle close to home. When the film is broad and the mass is low, the sun itself is a gentle engine that never runs out. The footprint this trick leaves is obvious. A sail likes to be seen. It makes the point spread bloom, it invites glints, and it prefers profiles that look more like plates than stones. When you do not see that bloom, and you still see a push, a pure sail grows less comfortable. Dustless gas can do the job with a different accent. Warm a pocket of carbon monoxide or carbon dioxide, and it will escape through a vent and push the body the other way. Comets have written this story for centuries. In the easy cases, sunlight heats ice, gas bursts out, dust follows the gas, and a tail announces the process. In the harder cases, surface geometry focuses the jet like a nozzle, larger grains fall back, and the coma stays shy. If rotation is slow and the slit is steady, a body can sip thrust for hours with only a faint veil. The footprint this trick leaves is often color and texture. Narrow filters see a blush. Deep stacks see a skirt. Over many nights, a gentle wobble appears as the jet moves with the spin. If the profile stays clean and the push does not, the jet must be precise about hiding its crumbs. That is possible. It asks the sky for several favors at once. Heat itself can act like a tiny thruster when a warm surface radiates more strongly in one direction than another. The Yarkovsky effect is the textbook name. On rocks a few hundred meters across, the drift can change orbits over many years. The logic is patient and true. The footprint is time. You expect decades of whisper, not hours of decision. If you write a fit that only sleeps after an overnight push, Yarkovsky does not make a tidy pillow unless you twist many knobs at once, and then accept that the effect woke up just when geometry was most profitable. That is a lot of coincidence for a lecture that wants calm. There is also the idea of an electric sail. Threads set to a high voltage shape the solar wind and ride it like a river. The push comes from charged particles rather than photons. Laboratory work and studies have loved this idea for years. No propellant is needed, only fields and control. The footprint would be fickle. You would expect response changes when the wind changes. You would expect fits to prefer long-lived bias rather than a single tidy window. You might also expect radio fuss because high-voltage systems do not always keep quiet. In a sky that offered a short, tidy push and then fell back into silence, an electric sail feels like a song for another night. Cluster the numbers that belong in our pocket. Solar radiation pressure near Earth is about 10 micronewtons per square meter. Requested accelerations and odd fits often sit near a few millionths of a meter per second squared. A useful overnight push lasts a handful of hours. A clean way to buy that push is either a free force like sunlight on an enormous area, or a thrifty engine that spends energy at a small but steady rate. The sail path wants wide films and bright signs. The engine path wants a duty cycle, on for a few seconds, off for a few seconds. Let heat bleed. Repeat until the target drift is in the bank. Which footprints have we seen with 3I? We have seen a curve that rests only after a smooth term is added. We have seen scarce hints of any coma. We have seen geometry pick one profitable week rather than a season. These observations do not demand an engine. They do ask the sail story to bend very far to meet them. Now the sleepy lecture turns to the part that the cautious engineer and the skeptical poet can both accept. Propellant-less is not the same as reactionless. A sail trades photons for momentum. An electric sail trades charged particles for momentum. A thermal thruster trades heat for plume. There are speculative devices that promise thrust without reaction mass, but they do not have a home in the sober file tonight. What does have a home is low-thrust hardware we already understand. Ion engines and Hall thrusters accelerate ions to tens of kilometers per second and produce exhaust that is nearly invisible at great distance. They are most efficient when pulsed. 8 seconds alive, 12 seconds resting. Repeat for hours. The footprint they leave is not a bright tail. It is a patient change in a plot and a faint chance of radio heartbeat if a harmonic leaks from a housekeeping oscillator. Those are not myths, those are shop habits. Grounded speculation says a hybrid is possible without violating pride. A small reflective patch could raise area to mass for a short window and let sunlight do part of the work, while a tiny onboard driver provides the rest. The reflective patch could be natural, a bright plate of glassy crust. The driver could be no larger than a compact generator that produces a few kilowatts. The push would stay in the round numbers we have already accepted. The footprint would stay in the floor of most cameras. If geometry and luck lined up just once during a storm-filled week, a spectrogram might catch a faint ladder while the orbit absorbed a gentle turn. This is not Baroque, it is thrifty. It is how careful systems behave when fuel and time must both be saved. Hold one vivid image so the mind does not drown in terms. Imagine a dark shell the size of a small hill sliding through sunlight. No veil streams behind it, no plume waves. Every 10 seconds, deep inside the shell, a circuit clicks. For 8 seconds, something hums and ions hurry down a throat you cannot see. For 12 seconds, it rests and sheds heat into the cold. The cycle repeats. On a faraway wall, unseen by almost everyone, a pencil line that should be a perfect conic leans by a whisper. Hours pass. The lean holds. Weeks later, a scheduled look misses by a careful margin that feels like a decision more than a mistake. That is the scale we are discussing. Not thunder, not fireworks, a metronome and a ledger. The imaginative leap, set down with respect, is that there are ways to hide an engine inside the profile of a stone. Not by magic, but by design that values thrift and silence. A driver that vents neutral particles could leave almost no glow at distance. A driver that plays with charged particles could bleed a harmonic that hides near a band where many ears already listen to the universe itself. A driver that trusts low-duty cycles would pick windows when geometry multiplies effort and when news elsewhere keeps nerves quiet. None of those choices require a villain. All of those choices describe a pilot that prefers to arrive without applause. We close the lecture with a question that speaks in a library voice. If a body can move without a tail and prefers to move when attention is elsewhere, what kind of appointment is worth that patience? Sails do not care about secrecy. Engines that hide their breath often do. In the next room, we will trade theories for calendars. A date on the wall is approaching. Observatories have windows in December that assume a drift, not a driver. If the new acceleration holds, those windows may find only empty sky and a smear of doubt. The lesson of tonight carries forward. Thrift leaves lighter footprints. Lighter footprints are harder to chase, which is why the chase now shifts from physics to time. A calendar can be as sharp as a blade when the sky turns it the right way. The date that sits under a red circle is simple enough to say out loud. December 19th. A quiet week on most desks, a long corridor on scheduling boards where observatories protect a few hours for a traveler that was supposed to be docile. Those blocks were reserved using an older curve, the one that assumed drift rather than a driver. If the new acceleration holds, the appointment will be kept by the telescope and ignored by the target. Not a snub, a slide. The camera will open on time and find only neat stars and the faint perfume of empty space where numbers promised something small and stubborn. Hard facts first, so the pulse in your wrist can slow. Big observatories plan in windows. Hubble favors guide stars that keep its aim steady, each pointing lives inside a small box built from attitude limits, roll angles, and the time the spacecraft needs to slew and settle. JWST thinks in a broader geometry. It carries a warm sun shield that dictates what parts of the sky are safe in any given week. Both machines feed on ephemerides that are snapshots of the future, maps written in pencil that tell a camera where to look and when to start counting. If the target walks a few arc seconds away from the box by the time a door opens, the detector will do its job beautifully and still print an absence. The cruel truth of space is that excellence without coincidence is silence. Translate the new push into a distance you can feel. The fit asks for an acceleration around a few millionths of a meter per second squared, applied for a handful of hours. Round every number so sleep can keep hold. Think of a whisper that adds 3 millimeters per second to the speed and repeats until a slim pocket of delta Vive is in the bank. In a week, that pocket becomes a drift of thousands of miles. At tens of millions of miles from home, thousands of miles project to tens of arc seconds on the sky. That is not a canyon for a city. For a narrow camera, it is the difference between a clean acquisition and an empty field. Guidance loops do not wander the neighborhood. They stare at the spot you promised and wait. The geometry adds its own mischief. Uncertainty ellipses do not simply shrink when fits improve. They rotate. A corridor that once ran along the detector's long axis can, after a patient push, turn across the short axis where margins are tight. A telescope team can compensate, but not if the rotation happens between the planner's last good check and tonight's window. Slews take minutes, settles take minutes. Guide star catalogs are not at infinite. If the object has stepped sideways by a tidy number, the old stars may no longer anchor the new corridor without a full rewrite. That rewrite is a thing of meetings, not of seconds. The sky does not pause meetings. The shutter opens and records precisely what it sees. A rhythm belongs to the date, not because the day is special, but because duty cycles love leverage. If pulses ran for 8 seconds and rested for 12 during a single overnight push earlier in the month, the benefit would blossom later when triangles of sun, traveler, and observer became efficient. A pilot of thrift would aim those pulses where a centimeter per second buys a future of thousands of miles. A pilot of patience would place them during a week when dashboards on Earth were flooded with honest storms. The result is a December window built from last month's assumptions, trying to catch a body that has already paid for a different future. The slip is not theatrical. It is accountancy. Now imagine the room where the appointment lives. A clock ticks. An acquisition script runs. Guide stars lock. A short dither pattern makes the stars breathe in neat squares. The detector's first image arrives. It is beautiful in the way all well-made emptiness is beautiful. No smear announces speed. No coma advertises heat. Someone toggles a stretch and chases a faint knot near the rim that resolves into background. A second exposure leans the field by a planned few pixels. The knot stays put. The object is not there. The math is not wrong. The math is older than the decision the traveler made. Someone writes a sentence that will be read by almost no one outside the team. Field did not contain target. Recommend update to ephemeris and reschedule if possible. Grounded speculation gives the date a motive that is not romantic. December is full of constraints. JWST honors a field of regard that shifts with the seasons. Hubble shares time with other programs whose own guide star boxes are brittle. Holidays thin staffing for some ground segments. A slip of a few days can push a look into the new year where the geometry is worse and the corridor wider. If you wanted to dodge a deep stare with minimal effort, you would not need to outsmart anyone. You would only need to move far enough to force a temperate meeting to cool until January. Not a grand evasion. A polite slide across a calendar that is already crowded. There is a second motive that lives in the starfield itself. Instruments like quiet backgrounds for delicate work. Some patches of sky carry more galaxies and more structured noise than others. If a pilot wanted to avoid having its silhouette mistaken for a smear against a busy tapestry, it could choose to pass when the backdrop is unfavorable for detection. The choice would not be arbitrary. Shift the date by 2 days, and the parallax changes the pattern under the traveler by a tiny but useful degree. Shift by 4, and a planned filter set becomes less telling. None of this requires a villain. It is the craft of not being seen. The vivid picture is simple enough to carry with you after you close your eyes. Picture an observation plan taped to a console. In black ink, December 19th. In blue pencil, a corridor sketched like a feather where the target should drift. Over the feather, someone has stamped the small, calm word acquired. The image arrives and shows a perfect emptiness. Hours later, a revised ephemeris posts with a corridor rotated by a gentle angle that points into the corner of the old frame. 2 days later, a second attempt tries to thread the new feather and finds the body clipping the edge, too fast for a confident measure. There is no scandal in this. There is timing. The imaginative leap is light but sharp. Suppose the slip is not only about avoiding a look. Suppose it is about lining up with someone else's rendezvous clock. December 19th might be the date when a triangle needed to form somewhere far from cameras, a geometry that favors a handoff, a shade, a wake. The MRO strip that breathed of edges. The V1 pass that felt like a key. The faint ladder near 1.44 gigahertz that ticked like a metronome in a machine that counts heat. Each item lives on its own, but together they point to a habit. Do things when leverage is high and witnesses are distracted. Slide past appointments you did not choose. Keep the corridor wide until the last turn. The question at the end of the line is not whether December 19th was missed. The question is what the miss buys. A longer arc before the next deep stare, a better phase angle for a low duty cycle burn, a dark patch of background where a thin eyelash would drown, or something more pointed, a meet with a companion whose window could not move because its own fuel was thin. We cannot answer that in this room. We can only say that a new acceleration turns a calendar into a toolkit. The object is not rude, It is precise. If the camera looks into the wrong box this week, it is because the pencil moved. The hand that moved it counts seconds and prefers silence. In the next file, we stop circling the question and say it plainly. If lines are being brought together, then a lock is being set. The only thing left to name is the target. The room changes when a curve stops asking for explanations and starts asking for coordinates. A corridor becomes a box. The pencil that once traced options now draws a small, quiet square and writes aim inside it. Target lock is not drama. It is arithmetic made confident. Degrees of freedom are reduced. The fit, which needed a gentle, hours-long push to stop complaining, now grows calm when that push is applied with the same sign and cadence in test after test. Residuals stop wandering. The angle of error settles. The body behaves like something obeying a guidance law rather than drifting through a blessing of luck. Hard frames keep us honest. In navigation, a lock is not magic. It is the moment when the solution becomes stable under small perturbations. Nudge the assumed thrust by a fraction, and the predicted path no longer flails. The plane change keeps the same direction. The time of arrival moves by a handful of minutes rather than hours. When analysts slide the assumed duty cycle by seconds in either direction, the curve prefers the same rhythm that smoothed it last week. A driver that was hypothetical becomes a parameter you can fit. A destination that was everywhere becomes a place that tolerates fewer excuses. Where could that place be if thrift is the signature? Grounded speculation points to corridors that buy leverage without light. A trailing Lagrange region where sunlight hides behind geometry and a low duty cycle can stretch its budget. A shadowed slice of a magnetotail where plasma can be ridden like a river without raising a glow. A rendezvous triangle near a Trojan cluster where incoming speed is bled across weeks rather than burned down in a night. None of these require spectacle. All of them reward timing. The path we have watched, a push of a few millionths of a meter per second squared applied for hours inside a noisy week, moves the traveler toward that kind of economy rather than toward any stage fit for photographs. The file we built begins to click into itself. A narrow plasma thread that appeared twice like a thin breath near the line of motion. A spectrogram ladder near 1.44 gigahertz that ticked for minutes and then fell back into honest sky noise. A withheld strip from a Mars camera whose geometry, spacing, and faint lean were uncomfortable to caption. The week when storms owned the feeds and the orbit solution settled only with a patient term. December 19th marked with confidence by plans that were older than the nudge. Each item was bearable alone. Together, they speak the same sentence in different dialects. Control exists, and control prefers quiet. Let the imaginative leap be a single, careful step. Target lock may not be a bullseye on a rock. It may be a time-coded rendezvous with a moving frame, a coasting lane near a nodal crossing, a wake inside a larger field, a shade that sweeps along a line of points and offers cover for a handoff. A lock can be a phase, not a place. The guidance loop would declare success when a few small inequalities are satisfied: relative angle within tolerance, drift under a threshold, light time corrections within a window, and only then would the driver stop counting seconds. The satisfaction would not look like arrival to a camera. It would look like stillness in a plot and silence in a voice that had been tapping a metronome. What does it want at the end of that counting? The unsettling question is also the smallest. A pilot that values thrift does not waste Delta V on vanity. It leans because lines will meet. Those lines could end at a companion that once carried the name V1 and then fell back into the black to serve as a beacon only when needed. They could end at a region where fields are favorable and attention is inconvenient. They could end at nothing we can name, which is to say they could end at a convenience of physics that makes a job easier and a picture dull. None of those answers must be menacing. All of them reward patience. The work of the story ends here. The work of the listener continues in a different register. You are allowed to hold two truths at once: that storms on the sun were real and rightly commanded care, and that in their cover a small traveler may have counted seconds toward a new future. You are allowed to keep the word coincidence close and still admit that rhythms talking to rhythms is a persuasive music. You are allowed to sleep on it. Most mysteries require several nights to move from noise to shape. So, soften the room. Let screens dim to a low gray. Picture a quiet orbit traced in chalk and then traced again with a gentler hand that leans by a breath. The lean does not promise doom. It promises intent. Intent can belong to natural vents, behaving with unusual tidiness. It can belong to a sail that is smaller than our imagination prefers. It can belong to a driver that will never show us its breath, because silence is a design principle and not an accident. If you feel a tightness in your chest, let it go. The sky is large, the distances are merciful, and the language of guidance is slow by choice. We keep watch, we write clean notes, and we leave room for tomorrow to correct us kindly. Breathe in and out slowly, counting to 4. Above your roof, there are curtains of light folding and unfolding at the poles, and far beyond them, there is a pencil line buying a few thousand miles with patience. Power grids hum, and we'll be fine. Airlines choose smoother air. Engineers in quiet rooms reprocess a frame because care is their craft. Somewhere, a narrow tone rises and falls, and then is gone. If the traveler is steering toward a lock, we will meet that knowledge in rounded steps. A revised corridor here, a missed appointment there, a curve that stops us arguing when a tiny push is added at the right hour. None of this requires panic. All of it rewards calm. When you are ready, close your eyes. The universe is not in a hurry, and we do not need to be either. We will ask better questions in the morning. We will test the idea of a lock against new nights and kinder weather. If a key was turned, we will learn to name the door at a pace that respects both wonder and evidence. The channel will be here, unhurried, arranging the files in a sequence that lets your mind drift without losing the thread. For now, let the room darken. Let the lights of the city fade to a soft horizon. Somewhere, a small body leans into its future by the width of a whisper, and that is enough story for tonight.